Hi everyone, welcome to My Max Academy. In this video, we'll start with the chapter Continuity and Differentiability, which is your chapter 5 from your 12th standard CBSE Mathematics. So before we get started with continuity and differentiability, we will recap what we studied in our 11th standard about limit of a function. Limit of a function which you all had studied in your 11th standard. So before we understand continuity and differentiability, it is essential to understand limits which you all had studied in 11th standard, but I thought we'll just do a recap of what is limit of a function. Now what is limit of a function? Let's try to understand what is limit of a function. The limit of a function f is the value f of x is expected or assumed to take when the variable x approaches a particular value. When x approaches a particular value. So what is limit of a function? Limit of a function is the value that f is expected to take when the variable x approaches a value a particular value. For example, suppose if we say x approaches a, x approaches some number a is any number, any real number, then where does f of x go, or what is the value f of x is approaching? If I call that value as L, that value is L. Suppose even x approaches a is a real number and f is a real function, which means f is a function from R to R or a subset of R to a subset of R, which is R is a set of all real numbers. Then what value f of x is expected to take when x approaches a? And in symbol we write like this: if x approaches a, then f of x goes to L. And f of x approaches L when x approaches a, that is symbolically denoted as limit x approaches a or x tends to a, f of x value f of x is equal to L. Right? This in symbol we write it like this, which means when x approaches a, my f of x approaches L. My f of x approaches L. In symbol we'll say limit x goes to a, f of x equal to L. F of x equal to L. F of x equal to L means when x, that's a limit. When x approaches a, f of x approaches L. That is the meaning of this. Right? And this L is called as limit of the function. L is called as limit of a function f at x equal to a. At the point x is equal to a, the value L is called as limit of a function at x equal to a. Which means when x approaches a, we say at a, which means when x approaches a, your f of x approaches L. That's the meaning of this. In symbol, we write it as limit x goes to a, f of x equal to L, which means when x approaches a, my f of x approaches L. That's the meaning of that. And maybe this definition may be a little bit confusing or not clear. We will see some examples and you will be able to understand this definition or the concept of limit fully. So we'll go with example. Suppose we have an example. Let's take a function example. Let's take a function, say f of x. Suppose example 1. And f of x, we are defining a function as suppose x square minus 3. Now the question is limit when limit x tends to 4. When x tends to 4, f of x is what? Or in other words, what they'll ask is what is the limit? What is the limit of f? What is the limit of f at x is equal to 4? That is the question. What is it? R. What is the limit of f when x, limit of f at x equal to 4? What is the limit of f at x equal to 4? Meaning they are asking this, limit x goes to 4, x approaches 4, we can say, or x tends to 4 number, f of x goes where? When x approaches 4, where does f of x go? Or what value f of x approaches? We have to find it. So which means to find this, we will write limit x goes to 4, f of x, we have to find the value of this, that is equal to limit x goes to 4, f of x. What is f of x? X square minus 3. Let's substitute that function, x square minus 3. Right? Instead of f of x, I am writing this function. So I am just giving all this example which you had already studied in your 11th standard. No, I thought that we will just do a recap, so that it becomes easy to understand the concept of continuity especially. then after that we have differentiability. Right, now that is equal to, now if I substitute, right, x goes to 4 or x approaches 4, x square minus 3. Now in the place of x we have to put the limit. Now we are substituting the limit. When I substitute the limit, we will not write again limit x goes to 4. Now I am substituting the limit. When I substitute the limit, this becomes 4 square minus 3. In the place of x I am putting 4. Now what is 4 square? 16. So 16 minus 3, which is 13. So which means the limit, or I'll write here, limit x goes to 4, f of x is equal to 13. Limit x goes to 4, f of x is 13, which means when x approaches 4 or f of x approaches 13. In meaning of this is, I'm just writing this in the bracket. The meaning of writing like this is, when x approaches 4 or f of x approaches 13. That's the meaning of that. So this 13 is called as limit of the function at a point. The limit is always defined at a point. At a point means at what value of x. So 13 is the limit of the function at x is equal to 4. So what is the limit of the function at x equal to 4 means answer is 13. 13 is the limit of the function at x equal to 4, which we calculated in this way. Fine. So we'll take up one more example. I'll write it here. Example 2. Example 2. Suppose if you have a function f of x is equal to, suppose 2x minus 3. 2x minus 3. Now we want to find what is the limit. What is the limit of f at, this means f of, what is the limit of f, the function f at x is equal to, suppose 1. At x is equal to 1, what is the limit of f? So which means the solution will be, we want to find what is the limit of f at x equal to 1, which means we should find this limit x tends to 1 or x goes to 1, f of x is what? This is equal to what? We need to find this. The meaning of this, what is the limit of f at x equal to 1 means limit x tends to 1, f of x is what? Limit x goes to 1, f of x is what? So that is equal to, if you calculate, that is equal to limit x goes to 1, f of x. F of x is what? 2x minus 3. So we'll put 2x minus 3. Value of f of x is 2x minus 3. Now we are going to substitute the limit. Right? X goes to 1. This is the arrow. This is the arrow. X goes to 1. F of x. F of x is 2x minus 3. So I have substituted. Now substitute x equal to 1 here. Now we are substituting the limit. So it becomes 2 into 1. In the place of x I am putting 1. Minus 3. That is 2 minus 3, which is minus 1. So limit x goes to 1. F of x is what? Minus 1. Which means when x approaches 1, f of x approaches minus 1. F of x approaches minus 1. And this minus 1 is called as limit of f at x equal to 1. So if you compare this with this formula, you compare this with this, when x approaches a, here x approaches 4, f of x is some value L, f of x is 13. So your L is 13. Your L is 13. So your a is 4. A is 4. Similarly here, if you see, your a is 1. If you are trying to find the limit at the point x equal to a, right, x equal to a, in general it will be x equal to a. Here a is 1. And what is the value of L? L is minus 1. L is called as the limit of the function at the point x equal to 1 here. Fine. So now, suppose if you observe, suppose these two examples, suppose if you observe, right, what we have is, see, we have this our real number line, right? This is our, say, suppose minus, this infinity and this minus infinity. Right? So this is our 0. Suppose if we take the point 4, so 4 comes somewhere here. Suppose 4 is here. The point x equal to 4, 4 is somewhere here, suppose. Now, when we say x approaches 4, which means x is going towards 4, or x goes towards 4. When we say limit x goes to 4 means x is approaching 4, or x is tending towards 4. Right? So which means the values of x is approaching 4. So which means x is slowly becoming 4. When x is approaching 4, these are the values x can take, because these are real numbers. X is all real numbers, because f is a real function, which means f is a function from R to R. or a subset of R to subset of R. So these are your x values, right? When x approaches 4, which means x is going towards 4. When we say x is approaching 4, it can either approach in this direction to 4 or in this direction to 4. So there are two ways we can approach 4. Either you can approach from the left side of 4, or you can approach the 4 from the right side of 4. Right? Similarly, same with the case of 1. If you have 1 here, I can approach my 1 through the left side of 1 or right side of 1. For that matter, for that fact, or for that matter, any number, we can approach in two different ways, to the left side of that number and right side of that number. There are two ways to approach. So here when you say x goes to 4 f of x means I can approach in any way. Either I can approach from the left side or right side. Any side if I approach, if x approaches 4, from any side of 4, either from the left side of 4 or right side of 4, if I am approaching 4, then f of x approaches 13. Right? So since we have two ways to approach the 4, either from this direction, from the left side of 4 or the right side of 4. When we approach left side of 4 means, which means we are approaching like this. Suppose this is 3. Let's assume that it is 3. Just take, suppose this is 3. Then this may be 3.1, 3.2, 3.3, 3.4, 3.9, 3.99, 3.92, 93, 3.99. Like that we are approaching. So all these 3.9 will go 3.9 to 1, 3.92, 3.93. Like that we are going towards what? 4. In this direction. In the left hand direction, we are approaching 4 through the values. These values are what? These values are less than 4. When you approach 4 from the left side means we are approaching 4 through the value less than 4. Because we are approaching towards this value. Any value if you take, any x I take from this side, from the left side of 4, that will be less than 4. This is a real number line. This is our usual line. So here you have -1, -2 and all that. Right? After this 4, 5, 6, it goes on. So when you approach 4 from the left side, which means we are approaching the 4 through the values less than 4. We are going towards 4 through the values less than 4. When you approach 4 from the right side, so from this side if you approach, we will approach like this. This value, maybe this may be 4.9, 4.8, 4.7, like that. So when we approach 4 from the right side of 4, which means when we are approaching the 4 through this direction, which is the right side of 4, then the values will be greater than 4. So we are approaching 4 through the values greater than 4. So which means we will approach 4 through the values like 4.9, 4.8, 4.7, 4.6, like that, 4.01, 4.02, we'll approach 4. So here it will be like coming towards 3.99, 3.999, then we'll approach 4. So which means this is your left side, the values are less than 4. When you approach 4 from the right side of 4, which means the values are greater than 4, which means we can approach 4 in two ways, either from the left side of 4 or from the right side of 4. When we approach 4 from the left side of 4, then the values are less than 4. When you approach 4 from the right side of 4, then the values are greater than 4. So which means x can approach 4 in both the directions. So that gets us into another definition called as left hand limit and right hand limit. Left hand limit and right hand limit. So what is the left hand limit? Suppose if x approaches 4 through the direction left side of 4 or through the values less than 4 or from the left side of 4, that is called as left hand limit. And what is the value of f? That f is called as left hand limit. If x approaches 4 through the values greater than 4, then what is the value of f of x? That is called as right hand limit. So that gives us definition of left hand limit and right hand limit. Now let's try to understand what is left hand limit, what is right hand limit, and how they are related to limit. Right? So now we'll try to understand what is called as left hand limit of a function. So left hand limit, left hand limit, left hand limit. In short, we call it as LHL. Left hand limit. Yes. So the left hand limit of a function f is the value f of x is expected or assumed to have when the variable x approaches a particular value when x approaches a particular value a through the particular value when x approaches a particular value a through left side of a when x approaches a particular value a through the values on the left side of a through the values on the left side of a. That is called as left hand limit. So left hand limit is what? The left hand limit of a function f is the value f of x is expected or assumed to have when the variable x approaches a particular value a through the values on the left side of it. So in simple, so what it means is your x is approaching a, one value a, through the value less than a, or to the value on the left side of it. Left side of means less than a. We can also call it as less than a. I'll keep it as left side of a. So which means x approaches a, and we'll put a sign minus here. So what is the meaning of minus? Means x is approaching a through the value left side of a, which means through the value less than a. Then, and if f of x, suppose if approaches the value L, when x approaches a is any real number, when x approaches a, and then we put a symbol minus here on top of a, which means when x approaches a through the left side of a, which means through the values less than a, then f of x, if suppose f of x goes to L, then we call the left hand limit as L, which means in symbol we'll write this as limit x goes to a minus f of x is equal to L, which means this is called as left hand limit. We call this as LHL. LHL is what? LHL is left hand limit is limit x goes to a minus f of x equal to L, which means when x approaches a through the value less than a, or f of x is equal to L. This is called as left hand limit. Right? I will give you an example to explain left hand limit and right hand limit. First we will try to understand the definition, then we will go to examples. That way you will be able to understand what is the left hand limit, what is the right hand limit. Now we will try to understand we will try to write the definition of right hand limit. Now right hand limit, which we call it as RHL, which is called as right hand limit. So the right hand limit, we'll write the definition of right hand limit. The right hand limit of a function, f is the value. The definition is same as this. Only thing is we'll say x approaches value a through the values on the right side of a. So is the value f of x is expected or assumed to have when the variable, or we can say when x approaches, when the variable x approaches a particular value say a through the values through the values on the right side of through the values on the right through the values on the left side of through the values on the right side of a through the values on the right side of a, that is called as right hand limit, which means when x approaches a through the values on the right side of a, which means suppose if you take this example of 4, we are approaching 4 through the values greater than 4, which means from the right side of 4, that is denoted as x approaches a plus, then f of x approaches, suppose limit, suppose k, it approaches the value suppose k, then we write in symbol limit x goes to a plus means x is approaching a through the values greater than a or through the values on the right side of a. Plus means left side of a, which means less than a. Sorry, minus means through the value on the left side of a or less than a. Plus means through the value on the right side of a or greater than a. So limit x goes to a plus f of x is equal to k. Limit x goes to a plus f of x is equal to k. What is the meaning of this? When x approaches a from the right side of a or greater than a, then f of x approaches k. This is called as right hand limit. This is called as right hand limit, and then we say that limit exists. And see, for every function we need to find the left hand limit and right hand limit, or we can find left hand limit and right hand limit. And whenever we say limit will exist, we'll say limit exists. Limit exists if your left hand limit is equal to right hand limit. Whenever your left hand limit and right hand limit match, then we say limit exists, which means we'll say limit x goes to a, f of x exists. So limit exists if LHL and RHL are same, which means if your LHL is L and if your RHL is K, if L and K are equal, then we will say limit x goes to a, f of x is equal to L. We will not put either minus or plus. This is a definition of the limit which we had studied earlier, where when x approaches a, f of x equal to L. That is called as limit of the function, which means x approaches a means x can approach a through the value less than a or greater than a. Either case, your L and K are matching. When L and L are equal, we can say limit x goes to f of x is equal to either L or K because both are same. Then in that case, we will say limit exists. If L is not equal to K, if LHL is not equal to RHL, then we will say limit x goes to a, f of x will say does not exist. Does not exist, which means there is no limit. Limit x approaches a, f of x does not, is NOT not. I'll write like this, NOT not. If LHL is not equal to RHL, then limit x goes to a, f of x does not exist. So for the limit to exist, we say limit here, we don't say left hand limit or right hand limit, which means the a can be approached in any direction. Whichever direction you approach a, your f of x approaches L. Here L equal to K. If L equal to K, the limit x goes to f of x equal to L, we can put R K because L and K are equal. Left hand limit and right hand limit are equal. Suppose this value is 5 and this is also 5. Or this is also 13, this is also 13. Then we will say limit x goes to f of x is 13. Suppose if they are different, suppose here I get 13, here I get 11. Then we will say limit does not exist. Which means we don't know. When x approaches a, where f of x will approach, we don't know. So we will say limit does not exist. So I will give you some examples wherein you will be able to understand what is left hand limit, right hand limit, and when do we say limit exists. When do we say limit exists? Fine. So let's take an example, which is, suppose if f of x is, so we'll say example 1, f of x, suppose if f of x is equal to x square plus 3. Now what we should find? We should find limit. Suppose x goes to say any value, say x goes to 2. Limit x goes to 2, f of x is what? That's the question. Then whenever we need to find the limit, for the function at the point x is equal to 2, if you want to find this value, we will try to find the left hand limit and right hand limit. If left hand limit and right hand limit both match, then we will say limit exists. So to find the left hand limit, the solution is, we can even directly find the limit. I will tell you directly also we can find the limit. Now since we learned left hand limit and right hand limit, we will try to find the LHL and RHL. Solution is, let's find LHL. Left hand limit. How do we find the left hand limit for this? That will be limit x goes to 2 minus f of x. What is f of x? We have to find. That is equal to limit x goes to 2 minus, which means x is approaching 2 through the value less than 2. So f of x is x square minus 3 or plus 3. Sorry. F of x is x square plus 3. Now we will substitute the value here. Substitute the value, x approaches 2, x square plus 3. If you substitute the value, you get 2 square plus 3. Now we are substituting the limit. So 2 minus means don't think it is minus 2. It is x is approaching 2 through the value less than 2. That is the meaning of this. Which means if you have the number line, so this is your 0, this is your infinity, minus infinity, plus infinity, this is your 2, suppose. And this is our 2 means we are approaching 2 through this direction. That's the meaning of 2 minus, from the left side of 2. This is your 2, this is the left side of 2, this is the right side of 2. This is your right side of 2. So f of x is this. So now if you substitute the limit, in the place of x you have to put 2. So you get 2 square is 4 plus 3 is 7. So your left hand limit is what? So limit x goes to 2 minus f of x is 7. Now let's try to find what is our right hand limit. Our right hand limit is limit x goes to 2 plus. For right hand limit we should put limit x goes to 2 plus f of x. F of x, that is equal to limit x goes to 2 plus. 2 plus means x is approaching 2 through the values greater than 2. X is approaching 2 from the right side of 2. Which means from this direction we are approaching 2. If you approach 2 in this direction, this left hand limit. If you approach 2, this is right side, you are approaching 2. If you approach 2 from this side, this left side, you are approaching 2. So we are approaching 2, x is approaching 2 through the values greater than 2. That in symbol we write it as x goes to 2 plus f of x, that is limit x goes to 2 plus f of x. F of x is x square plus 3. Right? So that becomes, now if you substitute 2 here, we not put 2 plus. The plus denotes we are approaching 2 through the value greater than 2 or through the values on the right side of 2. Now if you substitute 2, you get 2 square plus 3, which is also 7. So your right hand limit x goes to 2 plus f of x, that is also 7. Your left hand limit is also 7. So both the limits are matching. Right? So which means LHL, left hand limit, is equal to RHL. Because both your left hand limit is also 7, right hand limit is also 7. So now we will say limit x goes to 2 f of x is equal to 7. Here we will not put plus or minus, which means your x can approach 2 from any direction, from the left side of 2 or right side of 2. Your limit is 7. So limit x goes to 2 f of x. Value of this is 7, which means when x approaches 2, f of x approaches 7, or f of x goes towards 7. That's the meaning of that. Fine? Okay. Now we'll see another example. Example 2. Suppose if we have a function f of x. Suppose if the f of x is equal to x square minus 4x. So we'll define f of x like this. When x is greater than or equal to 2, and minus 2x when x is less than 2. Right? This is how the definition of the function. F of x is x square minus 4x when x is greater than or equal to 2, and it is minus 2x when x is less than 2. Right? Now we need to find. So suppose the question is find limit x goes to 2, f of x is what? Limit x goes to 2, f of x is what? Again x is approaching 2. What is f of x? Now the solution is, now to find the limit x goes to 2 f of x, we must find left hand limit and right hand limit. We must find left hand limit and right hand limit, and especially we go for left hand limit and right hand limit. We can go for all the cases, but generally when your f of x is only single function x squared plus 3, we can directly go for the limit, like how we did the limit when I wrote the definition of the limit, and then we directly calculate. In this case we didn't have to calculate left hand limit and right hand limit. Even if you calculate it is fine, but whenever you have a case where f of x is having two definitions based on the value of x, and that it has two definitions based on the value of x, at which point it is changing. The definitions are changing at the point 2, and if you want to find the limit at that point where the function is changing, the function is changing at the point, because greater than or equal to 2 it behaves like this, the function is this, less than 2 it is like this. And whenever you want to find the limit of the function at that point, then we must find left hand limit and right hand limit. So to find this limit, we should find left hand limit, we should find right hand limit. If both match, then we will say limit exists. So let's find what is our left hand limit. So let's find LHL. Left hand limit is limit x goes to 2 minus, right? We are finding left hand limit, so we'll put limit x goes to 2 minus f of x. That is equal to limit x goes to 2 minus. Now f of x, we have a confusion now whether to use this function or this function. Now to use this function or this function, we have a confusion, because here it was only a single function x squared plus 3. So here we substituted, instead of f of x, we substituted x squared plus 3. But here you have two definitions. We don't know which f of x I should substitute. Should I need to substitute f of x as like this or minus 2x? Now it depends on the value of x. Now we must find what is the value of x. What is value of the x is approaching 2 through the value less than 2. Minus means less than 2. So this is your number line. Suppose if this is 2, and if you are approaching 2, x is going towards 2 through the value less than 2 means x is coming towards 2 in this direction, left hand direction. So in this direction, what will be the value of x? So x can take something like 1.1, 1.2, like that it will go. Here it will become 1.9, then it will become 1.99, 1.991. So if it keeps on approaching 2, it will never go to 2, it will never touch 2, but it is approaching 2, which means it is going nearer and nearer to 2. So some x, if you take very close to 2, you have to find an x very close to 2 but less than 2. Suppose we can take it as 1.99. If you want to go much more closer to very close, the value should be very close to 2, we can take it as 1.99. Now this is your x. The x will keep changing, and then it's keep on moving. So it will become 1.999. It will go to 1.9999. So it is going towards 2. So these are your x values, and these x values, suppose if we take a particular value of x, let's take this value 1.99, or this is 1.999, whichever value. Now this is your x. Now take this x. So x is approaching 2 through the value less than 2 means x can take any of these values. Now I am taking one of the values which is very close to 2 but less than 2, because it is 2 minus. So you have to find the value of x which is very close to 2 and less than 2, which is 1.999. Now this is your x. Now check whether this x is greater than or equal to 2 or less than 2. Now 1.999 is less than 2. 1.9999 is less than 2. So we should use this function. We should use this function because x is approaching 2 through the value less than 2, which means x is less than 2. When x is less than 2, the function is minus 2x. So minus 2x. Now we will substitute the value. Now we will substitute x is equal to 2. Don't put minus 2. 2 minus means it's not minus 2. X is going towards 2 through the value less than 2. To denote it is approaching 2 through the value less than 2, we are putting minus here. So we have to put x is equal to 2 here. Now you put x is equal to 2, this is minus 2, x is 2. So 2. We are substituting x as 2. Now what do we get? Minus 4. So that is our left hand limit. Limit x goes to 2 minus f of x is what? Minus 4. F of x is minus 4. Now let's find what is our right hand limit. Right hand limit. That is limit x goes to 2 plus. For right hand limit it is 2 plus f of x. F of x, that is equal to limit x goes to 2 plus, which means x is approaching 2 through the value is greater than 2. That's the meaning of 2 plus, which means we are approaching x 2 through the value greater than 2 or from the right side of 2. That's why it's called as right hand limit. We are approaching 2 from the right side of 2. So which means we are approaching like this. This is your right side, right of 2. Right side of 2, this is your left side of 2. Right side of 2, this is left side of 2. So when you approach 2 through this value, so these values will be what? Will be like 2.1, 2. 2.01 like that. So these values will be what? It will be like 2.1, 2.01, 2.001, 2.0001. So it is approaching 2 through the values greater than 2 or the right side of 2. So these are your x's. So this is your 2, these are your x's. So we are approaching 2 through these values. These values were what? These values could be any of these values. Suppose if you take any one of the values, suppose if you take 2.001, that is your x. Because we have to decide which f of x we have to use here. We have two definitions. To decide which f of x we should use here, we should know what is the value of x. Because depending on the value of x, the f of x will change. Now here the value of x is what? You can take any one of these values. You take any one of the value on the right side of 2. Any one value which is very close to x, but on the right side of x. Right side of x means greater than right side of 2. Right side of 2 which means greater than 2. So that will be what? If you take this value 2.001, we can take any one of the values. Let's take this value. Now this value is your x. Now x is greater than or equal to 2 or less than 2. So this value is x. Is 2.001 greater than or equal to 2 or less than 2? It is greater than or equal to 2. We should use this function. Now we will put x square minus 4x here. Put x square minus 4x. Right. So depending on the value of x, we must choose the function. Because when x is less than 2, this function we have to use. When x is greater than or equal to 2, we have to use this function. Now if you use this, now if you substitute the limit, in the place of x we should put 2. So we get 2 square minus 4 into 2. So that will give you 4 minus 8, which is minus 4. Now, so your right hand limit is what? Limit x approaches 2 plus f of x is minus 4. Our left hand limit is also minus 4. Right hand limit is also minus 4. Right? So your left hand limit is equal to right hand limit. So therefore we can say, therefore what we got here is the left hand limit is equal to right hand limit. So we'll say LHL equal to RHL. What we say? We say that LHL is equal to, so LHL equal to RHL, because both are minus 4, so therefore left hand limit is equal to right hand limit. So we'll say limit x goes to 2 minus f of x is equal to limit x goes to 2 plus f of x, and both are equal to minus 4. Both the left hand limit is also minus 4, right hand limit is also minus 4. Both the limits are same. Therefore we will say limit x goes to 2 f of x, which means whichever direction x approaches 2. That is the meaning of this. When x approaches 2 means whichever direction it approaches 2, x approaches 2, then your f of x will go towards minus 4. F of x will go towards minus 4. So that is the limit of the function at the point x is equal to 2. So limit x goes to 2, f of x for this function is minus 4. Right? So all of you can take this notes. So we'll do one more example. Let me erase this. Suppose if you have a function. One more example. So that way will be very clear. So next one is, suppose if you have a function. So it's another example 3. Right? Suppose f of x is a function. F of x is defined as, suppose f of x is defined as x cube plus 1 when x is greater than or equal to 1, and it is 3x when x is less than 1. Now this is the question, and we have to find, what we have to find is find limit x goes to 1 f of x is what? When x approaches 1, right? Limit x approaches 1, f of x is 1. We have to find the limit of the function at the point x is equal to 0, x is equal to 1. We have to find the limit of the function f at the point x is equal to 1. So to find this, we have to find the left hand limit and right hand limit. That's a must here, because the value of the function changes depending on the value of x, and that change happens at the point 1. At 1 less than 1 it behaves in one way, greater than 1 it behaves in another. So, and we are asked to find the limit at the point x equal to 1 where the function is actually changing. Then we must find left hand limit and right hand limit. Only then we can conclude whether the limit exists, which means whether the left hand limit is equal to right hand limit. If it is equal, then the limit exists, and we'll write what the limit is. If it is not, when LHL is not equal to RHL, when left hand limit doesn't match with right hand limit, then we will say limit does not exist. So solution is To find this limit, we'll find left hand limit. LHL. What is left hand limit? We'll say limit x goes to 1 minus f of x. That is equal to limit x goes to 1 minus f of x. Now we need to know which function we have to choose. Now x is approaching 1 through the value less than 1. When x approaches 1 through the value less than 1, means suppose if this is your number line and our 1 is here, we are approaching 1 through this side, through the left side of 1. So which means these values will go through the left side of 1 will be what? 0.6, 0.7, like that it will go, this will be 0.9, 0.99, like that, 0.99, like that it will go towards 1. This is your 1. So 0.99, 0.999. So these values will be like this. So what is our x? We can choose any one of these values. We have to choose a value very, very close to 1 but less than 1. We choose one x which is very close to 1. We'll choose an x which is very close to 1 but less than 1. So which means 0.99 or 0.99. Now check whether this 0.99 is less than 1 or greater than 1. Now it is less than 1 because 0.99 is less than 1. So since it is less than 1, we have to choose this function. We have to put this function 3x here and not this function. Because x is approaching 1 through the value less than 1, because which means all your x will be less than 1. X will take different values. As it approaches towards 1, it will have different values, 0.9, 0.99, 0.999, 0.999. It is going towards 1. It will never touch 1, but it is very, very close to 1. Which means all the values on the left side of 1 will be less than 1. Which means f of x should be 3x. Now we will substitute the value of, in the place of x, we will put 1. It's not minus 1 again. 1 minus means it is approaching 1 through the value less than 1 or through the values on the left side of 1. Right? This is left side. This is left side. This is right side. We'll come to that right side. So we'll put 1 here. Now we'll get 3 into 1. That is 3. So what is our left hand limit? The left hand limit x goes to 1 minus f of x is 3. That is 3. Now we should find the right hand limit, RHL. So RHL is what? Limit x goes to 1 plus f of x. Right? That is equal to limit x goes to 1 plus. Now x is approaching 1 through the value greater than 1. X is approaching 1 through the values greater than 1. So which means x is approaching from the right side. X is approaching 1 plus means x is approaching 1 through the values greater than 1 or through the value on the right side of 1. So through these values. So here the value will be what? 1.5, 1.6, sorry, 1.4, 1.3. Like that it will approach. So it will be 1.1, 1.01, 1.001. So it will be like these. The values on the right side of 1 will be like this. And very, very close to 1. So we should pick up a value. Suppose if I take a value, this is very, very close to 1 but greater than 1 means suppose if this, that is 1.001. 1.001. So x is what? 1.001. When x is 1.001, is it greater than or equal to 1 or less than 1? This value. This value is 1.001 is greater than or equal to 1. Therefore, we should use this function x cube plus 1. Because your x is approaching 1 through the values greater than 1 or right side of 1. Right side of 1 means greater than 1. So x is, so all the x is greater than 1. When x is greater than 1, x cube plus 1 is the function. Now we'll substitute the limit. Put in the place of x, put 1. So we'll get 1 cube plus 1, which is 2. So what is our right hand limit? Limit x goes to 1 plus f of x is 2. Now our left hand limit is 3, right hand limit is 2. So your LHL, left hand limit, is not equal to RHL. So since our left hand limit we call it as 3, right hand limit we call it as 2. So left hand limit is not equal to right hand limit. Therefore, we'll say limit does not exist. Therefore, limit x goes to 1 f of x. This is what we are supposed to find. Right? Limit x goes to 1 f of x does not exist. Does not exist. So we cannot say what is the limit x goes to 1 f of x is what? We don't know, because when you approach 1 through the left side of 1, it is f is going towards 3. When x approaches 1 through the value is greater than 1 or the right side of 1, f of x approaches to 2. Then your left hand limit is 3, right hand limit is 2. When they don't match, left hand limit doesn't match with the right hand limit, then we will say limit does not exist. Limit x goes to 1 f of x, value is what? We don't know. It does not exist. And then we should stop here. We should stop here. Now all of you can take this notes Now the next one is what we have is continuity. Now this will give a brief idea about what is limit of a function, what is left hand limit and what is right hand limit. Now we'll go to the next section, which is called as continuity of a function. Right? All of you can take this notes. I'm erasing. The next concept is continuity. Continuity, or what is called as continuity. So the definition for continuity is a function f is said to be continuous at a point x equal to a if limit x goes to a f of x should be equal to f of a. We say a function f is said to be right? We say a function f is said to be continuous at a point x equal to a if limit x goes to a f of x equal to f of a, which means we should find the limit of the function at the point x is equal to a if the limit matches with the actual value of the function. F of a means it is the actual value of the function. So the meaning of this is when x approaches a, f of x approaches some value L, and f of a means it is the value of the function. This is f of a. Suppose if the f of a is equal to some value k, which means x is equal to a, f of a is k. F of a is k. Suppose f of a is k means what? This is the actual value of the function when x is equal to a. When x is equal to a, f of x is equal to k. When x equal to a, f of x equal to k. That is the meaning of f of a equal to k. F of a means the value of the function at the point x equal to k. When x is equal to a, the value of the function at x equal to a. When x is equal to a, your f of x is k. Here when x is going towards a, x is not equal to a here. X is going towards a. What is your f of x? That is called as limit. This is called as limit. This is the actual value of the function at x equal to a. So which means when the limit of the function matches with the actual value of the a at that point, then you call that function is continuous. A function is said to be continuous if the limit of f at the point x equal to a matches with the value of the function at the point x equal to a. This is called as value of the function at x equal to a. Right? So I will give few examples, then you will be able to understand what this definition is of. Right? So again I am reading the definition. A function f is said to be continuous at the point x equal to a if limit x goes to a, f of x equal to f of a. So we'll find this. If both match, then we will say the function is continuous at the point x equal to a. If they don't match, then we will say the function is not continuous at the point x equal to a. And so we'll take one example. I will take an easy example. So example 1. Suppose f of x, function f of x is, we'll take the same function x square plus 3. Now the question is f continuous? Is f continuous at, we can say x is equal to, we can choose any point. Suppose x is equal to 3. We want to check whether f is continuous at the point, say x is equal to 3. Now we need to check whether this function f is continuous at the point x is equal to 3. Now to check f is continuous at x is equal to 3, so your a is 3. So solution is Now we must check whether f is continuous at this point x equal to 3 or not. So for that we'll say, so we need to check whether f is continuous at x equal to 3. The question is f continuous at x equal to 3? Now for that we need to check if this value, which limit x goes to a is what? 3. Whatever the value x is, that is a, that is 3, limit x goes to 3, f of x should be equal to f of a is 3. So in this formula you have to put a equal to 3. If x equal to 3 means x is equal to a here. If x equal to a means this is the condition for f to be continuous. If x is 3, then in the wherever a is there you have to put 3, which means limit x goes to 3, f of x should be equal to f of 3. If we can show that these two are equal, then we can say that f is continuous at the point x equal to 3. Now let's try to find the function value first. What is f of 3? That is easy to find. What is f of 3? F of 3 means f of x is what? F of x is x square plus 3. F of 3 will be, in the place of x I should put 3. So it is 3 square plus 3. Which is 3 square is 9. 9 plus 3 is 12. So that is my f of 3. This is this. Now let's find what is limit x goes to 3 f of x. Now to find limit x goes to 3 f of x, here we can directly find the limit. We need not have to find left hand limit and right hand limit. Even if you find, there is nothing wrong in finding left hand limit and right hand limit, but there is no necessity to find left hand limit and right hand limit, because the simple reason is that f of x is only one definition, x square plus 3. It's not having some function based on the value of x. If x is greater than 2, it is x square plus 3, and if x is less than or equal to 2, then it is some x cube minus 9 or whatever. So there is no two definition for the function based on the value of x. So it's only single definition. Right? So which means if you have just single definition, then we can directly find the limit. We didn't have to find, or we don't have to find left hand limit and right hand limit. Even if you find left hand limit and right hand limit, there is nothing wrong with that. Okay, so we can directly find the limit. Limit x goes to 3. So I am not finding LHL or RHL. I am directly finding the limit, which is limit x goes to 3 f of x, that is equal to limit x goes to 3 f of x. F of x is x square plus 3. Because f of x is only this definition. For any x, it is x square plus 3. Now we will substitute x is equal to 3 here. If you substitute x equal to 3, you get 3 square plus 3. We get 3 square plus 3. Now what is 3 square? 3 square is again 9. Limit x goes to 3. F of x is x square plus 3. That now we are substituting the limit here. Now once I substitute the limit, I need not write again limit x goes to 3, because we have substituted the limit here. In the place of x, I am putting 3. So 3 square plus 3, which is 9 plus 3, which is also 12. So our limit x goes to 3 f of x, that is also 12, and the f of 3 is also 12. So f of 3 is also 12, this value is also 12. So which means both these two are matching, which means this is 12, this is also 12. Which means both are matching. So therefore we can say limit x goes to 3 f of x is equal to f of 3, and both are equal to 12. Both are equal to 12. F of limit x goes to f of x equal to f of 3. So we got this condition. Therefore we can say f is continuous at x is equal to 3. So at the point x is equal to 3, this function is continuous. At the point x is equal to, because we got limit x goes to 3 f of x matches with f of 3, because this value that we calculated, that is 12, and this value f of 3, that is also 12, both are 12. So both are matching. Therefore this definition is taken care of, this condition is satisfied. Then we can say f is continuous at x equal to 3. Fine. So all of you can pause the video and take the notes. We will go to another example. Suppose example 2, next example. Suppose our function f of x. Let's define the function f of x is 1. I'll take the same thing which is in your book, page number, in chapter 5, page number 147 in your textbook. F of x is defined as, suppose 1 if x is less than or equal to 0, and it is 2 if x is greater than 0. It is 1, f of x is 1 if x is less than or equal to 0. It is 2 if x is greater than or equal to 0. Now we must check Right? The question is, check if f is continuous. So is f continuous at x equal to 0? That is the question. So what is the definition of f of x? It is 1. It is 1 if f of x, if x is less than or equal to 0. It is 2 if x is greater than 0. Now, so solution. So to check whether f is continuous at x equal to a, we need to check this condition. So what we need to check? We need to check if limit x goes to 0, right? We need to check, I can say, we need to check if limit x goes to 0, f of x equal to f of 0. Right? To check at x equal to 0 whether f is continuous, we need to put the value of a here is 0 now. I have to put 0 here. So this definition will become limit x goes to 0, f of x equal to f of 0, because a is 0. So we need to check this condition. Now what is f of 0? Let's calculate what is f of 0. This is easy to calculate. What is f of 0? Therefore, when x is equal to 0, so when x is less than or equal to 0, this function. When x is greater than 0, f of x is 2. So when x is equal to 0, which means this condition. When x is less than 0 or equal to 0, f of x is 1. So f of 0 will become 1. What is the value of f of 0? It is 1, this function. So f of 0 is 1. We have calculated this. Let's find limit x goes to 0, f of x. So now to find limit x goes to 0, f of x, so if you see, here we must go for left hand limit and right hand, or we must find left hand limit and right hand limit. Why? The simple reason is that the f has two definitions based on the value of x. X has two definitions based on the value of x, and that two definitions are changing at what point? At point x equal to 0. So we go for left hand limit and right hand limit on what condition? Two conditions. F should have two definitions. F should have two definitions, and those two definitions should change at the point x equal to this point. What is this point? 0. At the point it is changing, and we are trying to check whether f is continuous at that point only. So whenever we want to find the limit at the point where the function is changing, whenever we want to find the limit at a point where the function is changing, the function is changing at the point 0, and we need to find the limit at the point x equal to 0, then we must go for left hand limit and right hand limit. So let's find what is LHL, left hand limit. We can't directly find the limit like this. Here we found directly because f was only one function. Here there were two functions, two definitions for the function depending on the value of x, and that value of x is what? At 0 it is changing. Less than or equal to 0 some value, greater than 0 some value, and we are finding the limit at the point 0. So we must go for left hand limit and right hand limit. So what is our left hand limit? Left hand limit is limit x goes to 0 minus f of x. For left hand limit means we write limit x goes to 0, then we put a minus, which means x is approaching 0 through the value less than 0 or the left side of 0. Right? Now that is equal to limit x goes to 0 minus, which means x is approaching 0 through the value less than 0. What is the meaning of x goes to 0 minus? Means x is approaching 0 through the value less than 0. So now we should take a value of x which is very close to 0 but less than 0. A value which is very close to 0 or less than 0. Let's take that roughly we'll write. So what is the value that is very close to 0 but less than 0? That will be like minus 0.01. There are many points, really many points. We'll take one of the points. So minus 0.01. Now x is minus 0.01. Since it's minus 0.01, now we'll go here. Is it less than or equal to 0 or greater than 0? This value is. So we are choosing a value x which is very close to 0 but less than 0. Why we are saying less than 0? Because it is negative, minus 0. 0 minus, or on the left side of 0. So we'll take that point as 0.01. So 0.01 is less than or equal to 0 or greater than 0? It's less than or equal to 0. So which means your f of x is 1. So in this case your f of x will be 1. What is the value of f of x? It is 1 because x is less than 0. X is approaching 0 through the value less than 0. So f of x is 1. So now if you substitute the limit 0 here, which means if you have an x here, you have to put 0, but there is no x. If you have an x here, in the place of x we should substitute the limit as 0, but there is no x, it is 1. So we'll write the 1 as it is. Only if there is an x we will substitute 0. There is no x. The function value is just 1. So whatever x is, your f of x is 1. So which means if there was an x, we would have substituted x as 0, but there is no x in the function. It is just 1. So your final answer is 1 after substituting the limit. If there is an x, we will substitute. So which means we are substituting. Since there is no x, we cannot substitute. So we will write this 1 as it is. So left hand limit is what? Limit x goes to 0 minus f of x is equal to 1. Limit x goes to 0 minus f of x is equal to 1. So that is your left hand limit. Now let's find what is our right hand limit. What is our right hand limit? So what is our right hand limit? Right hand limit is limit x goes to 0. We will take it as plus f of x. Limit x goes to 0 plus f of x. That is our left hand limit, right hand limit, right? Right hand limit is x is approaching 0 through the value is greater than 0. So that is equal to limit x goes to 0 plus f of x. Now x is approaching 0. Now we should decide f of x. Which f of x we should put, 1 or 2? For that we must find a value of x. We must find a value of x which is very close to 0 and greater than 0 because it is plus. So we have to find a value x which is very close to 0 but greater than 0. So very close to 0 greater than 0 means we can take x as 0.01 plus 0.01. So this value is very close to 0 but greater than 0. Now for this value of this, now let's check which function we have to use for this x. So x is 0.01. So 0.01 is less than or equal to 0 or greater than 0? It is greater than 0. So 0.01 is greater than 0. So we should use this function which is 2. Our f of x is what? 2. Now we should substitute the limit. Now we will substitute the limit when if you have an x, we can substitute. In the place of x, we have to put 0, but there is no x. So we'll just write this 2 as it is. Even if you substitute the limit x as 0, the final answer will be 2 only because there is no x. Only if there is an x, we will substitute x as 0 there. So it is just a 2. So which means our right hand limit, limit x goes to 0 plus f of x is 2. Limit x goes to f of x is 2. Limit x goes to 0 plus f of x is 2. So which means our left hand limit is 1 and right hand limit is 2. So which means they don't match. The left hand limit is not matching with the right hand limit. So we'll say LHL is not equal to RHL because your left hand limit is 1, this is your LHL, and your right hand limit is 2. So LHL is not equal to RHL. Therefore limit does not exist. Therefore limit x goes to 0 f of x does not exist. The limit will exist only when your LHL is equal to RHL. Only when your left hand limit is equal to right hand limit, limit exists. If not, you will say limit does not exist. Limit does not exist. So therefore, we will say since the limit does not exist, therefore we will say f is not continuous. Therefore f is not continuous at x equal to 0. Which means at the point x equal to 0, the question was, is f continuous at x equal to 0? The answer is f is not continuous. Why f is not continuous? Because limit does not exist. We cannot even find what is the value of this. This value we found, f of 0, we found it as 1. But the limit x goes to 0, f of x does not exist. Why the limit x goes to 0, f of x does not exist? Because your left hand limit is not equal to right hand. So since your left hand limit is not equal to right hand limit, so therefore limit does not exist. When limit does not exist, which means we cannot find this. Therefore we cannot say this and this are equal because we cannot find this. This does not exist. Therefore we can say f is not continuous at x equal to 0 because this condition is not satisfied. This value of this equal to this is not true because value of this is 1 but value of this we don't know. It does not exist. So therefore we cannot say these two are equal. We cannot say these two are equal. Therefore f is not continuous at x is equal to 0. Right? So this is how we will show that this function f is not continuous at x equal to 0. We will go to another example. So that is example 3. Suppose if we go to next, one more example. These are not examples in the book. We'll come to the examples in the book. This is my own examples. Just to understand the concept of continuity. Suppose if f of x is defined as f of x is equal to, suppose we define it as 1 f of x is 1 when x is not equal to 0, x is not equal to 0, and it is 2 when x is equal to 0. Now again the same question is f continuous at the point x equal to 0? That's the question. Now solution is, so similar to this, we need to check if limit x goes 0, f of x equal to f of 0. If this is true, then it is continuous. If not, it's not continuous. So we need to check. We need to check if limit x goes to 0, f of x is equal to f of 0. We need to check if limit x goes to 0, f of x equal to f of 0. If this is true, then we can say f is continuous at the point x equal to 0. So whatever 0 that you have to put here as well as here. Now let's find out what is f of 0. That is easy to find. What is f of 0? Which means when x is equal to 0. When x is equal to 0, what is f of x? F of x is 2. When x is 0, f of x is 2. Therefore, f of 0 will be 2. F of 0 is 2. So we have found f of 0. F of 0 means when x equal to 0, what is the value of f of x? F of x is 2. Now let's find limit x goes to 0, f of x. Now to find limit x goes to 0, f of x, we will find the left hand limit and right hand limit, because when x approaches 0, your function is having two definitions based on the value of x, and that value of x almost changing near 0 at this point. So we must find left hand limit and right hand limit. So left hand limit, to find limit we should find left hand limit and right hand. So left hand limit is limit x goes to 0 minus, we are finding limit x goes to 0, f of x means left hand limit will be, you have to put minus here, f of x, that is equal to limit x goes to 0 minus, now f of x. Now we should see whether we have to choose this function or this function. Now x is approaching 0 through the value less than 0. What is the meaning of this? X approaches 0 minus means x is approaching 0 through the value less than 0. Right? X approaches 0 minus means x is approaching 0, or x goes towards 0 through the value less than 0, which means your x is less than 0. When x is less than 0, which means x is not equal to 0. When x is not equal to 0, f of x is 1. So this f of x will be 1. When x approaches 0 minus means x is approaching 0 through the value less than 0, which means x is very close to 0 but less than 0. So any value x which is very close to 0 but less than 0 will be what? Minus 0.01. This point is very close to 0 but less than 0. When x is minus 0.01, which function will use? X is equal to 0? No, this is not equal to 0, which means x is not, because minus 0.01 is not equal to 0, therefore you have to use this function, which is 1. Now if you substitute the limit, in the place of x we should put 0. If there is an x, we have to put 0, but there is no x, it is just 1, so we will put 1. So left hand limit is 1. Now let's find what is our RHL, right hand limit. Right hand limit is limit x goes to 0 plus f of x. That is equal to limit x goes to 0 plus. Right hand limit means 0 plus, left hand limit means 0 minus. Limit x goes to 0 plus, f of x means x is approaching 0 through the value greater than 0, which means through the value on the right side of 0, which means through the value greater than 0. So we have to choose an x which is very close to 0 but greater than 0. That will be 0.01. Right? X is, we should choose an x which is very close. So we are choosing this x so that we will know which function we can use. For that, since this is f of x, I need to substitute here. So this f of x, limit x goes to 0 plus, f of x, I have written limit x goes to 0 plus, f of x, what will I substitute here? To know what, whether I should put 1 or 2. To know that, we will have to take a value which is very close to 0 but greater than 0, because 0 plus. So value which is very close to 0 but greater than 0 is 0.01. Now x is 0.01. Now is it equal to 0? This 0.01 is equal to 0? No, it is not equal to 0. So your f of x is 1 again. So now if you substitute the limit, in the place of x, if there is any x, we have to substitute 0. There is no x, this 1 will come as it is. So your right hand limit is 1. So your LHL is equal to RHL. So your left hand limit is also 1, your right hand limit is also 1. Therefore the limit is 1. Therefore limit x goes to 0 f of x, that is 1. We will not put plus or minus here, because it is the limit. Right? Therefore the limit x goes to 0 f of x is 1. So now limit x goes to 0 f of x, that is 1. Limit x f of 0 is 2. They are not matching. This value is 1. This value is 2. So this is 1, this is 2. So we will say therefore limit x goes to 0 f of x is not equal to f of 0. Because f of 0 is 2. this value is 1, this value is 1, this value is 2, so 1 is not equal to 2. These two are not equal. If these two are equal, this value and this value are equal, then we will say it is continuous. These two will be equal. Here these two are not equal because the value x goes to 0, f of x is 1, f of 0 is 2, so 1 is not equal to 2. Therefore, f is not continuous at x is equal to 0. So here f was not continuous because the left hand limit and right hand limit did not match, so we said limit did not exist. In this problem, earlier problem, a limit did not exist, so we said f was not continuous. But in this case, the limit exists and limit is 1. Limit exists, but the limit value is not equal to the function value. This exists, which is 1. This is 1, but it is not matching with the function value at x equal to 0. At x equal to 0, the function value is 2. They are not matching. Therefore, it is not continuous. Fine. So I'll do one more example. Suppose if you have a function f of x, okay, suppose another example. I'm not giving any name because these examples are not from the book. Example 3, I'm going to give another example 4. Suppose f of x is defined as, suppose if we define f of x as x cube plus 1, x cube plus 1 when x is greater than or equal to 1, and it is 2x when x is less than 1. When x is less than 1. Now the question is f continuous at x equal to 1? At the point x is equal to 1, we have to check whether f is continuous or not. So for that, solution is what? Solution is we need to check if limit x goes to 1, f of x is equal to f of 1. The general formula for the limit, general formula for the continuity is what? This is general formula. Limit x goes to a, f of x equal to f of a. If they are equal, then we will say it is continuous at x equal to a. But here a is what? 1. So we should say limit x goes to 1. Instead of a, we will put 1, f of x equal to f of a. A is 1. X equal to what value? We are checking the continuity of the function at what point? That point is a. Now we need to check this. If these two are equal, then we will say it is continuous. If they are not, then it is not continuous or discontinuous. Now what is f of 1? Let's find f of 1. What is f of 1? When x is equal to 1, f of 1 means x is 1. f of 1 means we have put x equal to 1. When x is equal to 1, when x is greater or equal to 1, this function. So f of 1 will be, we have to use this function because when x is greater than or equal to 1, we have to use this function. So f of 1 will be 1 cube plus 1, which is 2. So we have found this. Now we should find this. Now to find the limit x goes to 1 f of x, again f is having two definitions based on the value of x, and that value of x is, that change happens at the point x equal to 1. At the point x is equal to 1, the function definition is changing, right? The function definition is changing at the point 1. So we must go for left hand limit and right hand limit. Right? So to find this limit, we must go for left hand limit and right hand limit because f is having two definition and that definition changes based on 1. That this at x at the point 1 it is changing, and we are finding the limit at the point that point 1 1. So we must go for left hand limit and right hand limit. Now let's find left hand limit. LHR, left hand limit is limit colon x goes to 1 minus, left hand limit means 1 minus f of x, that is equal to limit x goes to 1 minus. Now we need to check which function we have to use. F of x should be what? What in the place of f of x, what should I substitute? Should I substitute x cube plus 1 or should I substitute 2x? And that depends on the value of x. Now x approaches 1 and there is a minus here, which means x is approaching 1 through the value less than 1. Minus means less, plus means greater than 1. So which means x is approaching 1 through the value less than 1 or left side of 1. Left side of 1 will be less than 1, right? So your 1 is here, suppose, right? Your 1 is here. It is coming towards 1 like this value. So here it is 1. So here you will have 0.5, 0.6, 0.7, 0.8 like that. So when x, so x is approaching 1 through the value less than 1. So we should take a value x which is very close to 1 but less than 1. Why less than 1? Because it is minus. Minus means less than 1. 1 plus means greater than 1. Here it is 1 minus. So we have to take a value x which is very close to 1 but less than 1. So very close to 1 less than 1 means 0.99 we can take. This value x is very close to 1 but less than 1. And it should be very close to 1. Which means 0.99 is very close to 1 but it is less than 1. Now x is 0.99. When x is 0.99, which category it falls? Whether this x 0.99, is it less than 1 or greater than or equal to 1? 0.99 is less than 1. So we must use this function 2x. So f of x will become 2x. Because your x is approaching 1 through the value less than 1. Which means your x is less than 1. Your x is 0.99, that is less than 1. We can take any value. There are many values which are less than 1. You can choose any one of the values. So I chose this value. With this value, we are checking whether x is less than 1 or whether this value is less than 1 or greater than or equal to 1. Since this value is less than 1, we have to this function 2x. Now we are substituting in the place of x, we should put 1. So it is 2x, so we will put 2 into 1, which is 2. So your left hand limit is 2. Now let's find what is our RHL, right hand limit. Right hand limit is limit x goes to 1 plus f of x. That is equal to limit x goes to 1 plus f of x. Now f of x, which function do we need to use? Whether x cube plus 1 or 2x. So for that, what do? We will have to take a value x which is very close to 1 but greater than 1. Why greater than 1? Because it is plus. Here it was minus, so we took a value less than 1, very close to 1, less than 1. Here we should take a value which is very close to 1 but greater than 1. So any value which is very close to 1 but greater than 1 means we can take x as 1.01. So this value is very close to 1 but greater than 1. This value is very close to 1 but greater than 1. So x is 1.01. Now based on the value of x, we will know which function we have to use. Now x is 1.01. Is it less than 1 or greater than or equal to? X is 1.01. So x is less than 1 or greater than or equal to? 1.01 is greater than or equal to. It's not less than 1. 1.01 is not less than 1. It is greater than 1. So we should use this function. So in this f of x, I will put x cube plus 1. Now we should substitute the limit. In the place of x, we should put 1. Don't worry about this plus. This plus says whether your x is approaching from the right side of 1. The plus says that your x is approaching 1 through right side of 1. Minus says your x is approaching 1 through left side of 1. Left side of 1 means lesser than 1. Right side of 1 means greater than 1. So now we need to substitute x equal to 1 here. In the place of x, put 1. So you will get 1 cube plus 1, which is 2. So now our LHL is also 2. Your RHL is also 2. So since your LHL equal to RHL, left hand limit is equal to right hand limit. Therefore, we will say limit exists. Limit x goes to 1. Here we will not put plus or minus. F of x is what? 2. Left hand limit is also 2. Right hand limit also 2 means limit is 2. Here this is called as limit, not right hand limit or left hand limit. Limit means your x can approach 1 through either side, left side also, right side also. Whatever side it approaches, your f of x goes to 2. So limit x goes to 1, f of x is 2. Now this value is 2. What is f of 1? That is also 2. So both are equal. This is also 2. F of 1 is also 2. Limit x goes to 1, f of x, that is also 2. Both are equal. Therefore, f is continuous. So we'll say, therefore we have limit x goes to 1, f of x is equal to f of 1. And both are equal to 2. F of 1 is also 2. Limit x goes to 1, f of x is also 2. Therefore, f is continuous. Continuous at x is equal to 1. At the point x is equal to 1, this function is continuous because this condition is satisfied. Limit x goes to 1, f of x is equal to f of 1. Both match. This value which we calculated as 2 and this value which we got it as 2, both are equal to 2. This is also 2, this is also 2. Therefore, both are equal. Therefore, we can say f is continuous at the point x is equal to 1. Fine. So all of you can pause the video and take the notes. Hope you all have understood the concept of limits as well as continuity of a function at a particular point. Fine. So I will stop the video here. You can watch my next video for the continuation of this. Thank you for watching. See you all in the next video. Thank you.